Go to TAPgiles.com to learn dreams, engage my services, and support the channel.
Cool, so the idea of this is it emits nodes in random places which push the ground down or pull it up. So I turn flat all the way down, you can see them all better. And then the ground kind of responds to any nodes that are close enough to that block. So first I'll need to explain just quickly about wireless receivers and how they are affected by multiple transmitters. So they'll communicate with each other even though they're not named, because they'll just communicate with each other by default. So let's get a readout of this. And we want to send a value in. So as we change the value in, we get the changed value out 1-to-1. And if you have more than one, it's not that useful. It's just the highest value. So that could be useful, but in this case not. We want to kind of average them out. So to do that, you can send fat wires, which you can do with a combiner. I just tend to put it onto 2. Put that in, and a fat wire is averaged out. So if all the fat wires, if you have multiple fat wires being sent to the same receiver, then it will average it out. So the average of 0 and 1 is 0.5, and it will kind of average out. So that lets us, if you imagine these in different spots around the map, then they'll all average out really smoothly for the blocks in between them. Anyway, we'll group those up with a fleck. You can't target individual gadgets to emit, but you can target a group. So that's why I tend to use a fleck. So in here, all we want to do is transmit, and I'll call it a seed to not confuse anyone. And we'll have a node in here, and we'll use the looped wire trick like that, and wire that into the seed. So it's transmitting from that spot whatever value we send it. So just to make sure that's working, I'm going to display this value as well. Like that, and I'll display it in the scene so it's next to the thing that we emitted. And then if I just get a value slider, I can tell it the value that we want. So it's 0.4, nothing interesting is happening yet. If we emit this, so I'll put it over there, and then I'll get an emitter. Okay, no speed, and we'll emit 0 time between emits, which means it'll emit once every frame. Now to kind of get some fake randomness, I'm going to use an action recorder and just like move it around a place like this. And now as it emits, it will be in these random places. And just make it super fast. Oh, if you get it just right, it starts looking very not random. There you go, so it's kind of random. That will do for now. And they've all got this 0.4, so if we turn off recycle, it will just make that amount of objects, and they've all got this 0.4 remembered. If we change this while it's emitting, then they'll have those different values that we set, so 0.2, 1, 0.4. That's what this looped wire is doing. It's remembering whatever it had at the time. So if we put in an actual random value, like here, signal generator, this generates values in various ways. We just want to use it for making random numbers, random percentage. So it's kind of got going up and down, up and down. If you adjust these, then you can say when it tries to go up, it's going to pick a random value between these, so a random percentage, and then we can do that for when it goes down. And now if we put this sweep seconds to 0, then every frame it's sending a new random value. So if we play it now, it's got proper random values all around the place. So that's cool. So we're transmitting those random values all in random spots over here. And now we're going to read those values with cubes on the ground, which make up the actual ground. So let's make a cube, and we're going to have a chip. We're actually going to group this up, not surface snap it. like that. And so we're going to get a receiver, and we want this receiver to be a decent size and have a lot of fall off. That means that even transmitters that are kind of far away will affect the value a little bit. So it can kind of it can kind of be averaged out all of the values within this area, is the idea. And then we'll use that to move this up and hue cycle it. So then we get like different colors depending on how high it is, and it's easier to see. And to make that more pronounced, I'm going to spray paint it red, so that when we hue cycle, it's like a nice bright whatever color, like that. And we'll just power that with whatever we get from the receiver. So if we put that here, okay, and as we move this around, you can see, depending on where it is, it's kind of got this nice smooth adjusting to the different kind of values. Okay, and now, whoa, so they're all affected by these values, which is cool. And if we, I think if I adjust that, yeah, so then we can still see the values, there we go. But they're all kind of adding to each other, so none of them are, they're not actually averaging out, they're just, where there are more, they're just, whichever the highest one is. It's like at the moment it's only getting the peaks, but we want to actually properly average out. So we'll just adjust what we're emitting over here, like we said before. So we'll have a combiner. So we get a combiner and put it into 2 because we've only got one value. And then we'll send that, and we don't need to send that anymore. And because we're sending a fat wire through with the 2 number type fat wire, we need to split it and get just the actual value that we are looking for. So because this object is turned off, the splitter doesn't really know what value is meant to be coming through here. So if we kind of fake it by using a combiner in the same type that we know it is meant to be coming in, and wire that in, now it kind of realizes that it's going to have this type. So now we wire A into the keyframe, and then we can delete that. And we don't need that, so we can delete it. Or you can leave it there so you can see these letters still. But if you delete it, it will just still work fine. And then it will have like the proper values. So now, oh, look at that. Oh, and it's kind of blending and stuff. Tasty. So if we just adjust that to be, so at the moment we're just getting a percentage. If we make it so that it kind of dips down a bit as well, then it will push down and pull up, depending on what values that it's actually set as. And if these were smaller, then it would be like a much finer effect. So if we make it smaller, oh, look at that. Nice. So ideally, now because they're so small, it would be better for them to be a bit bigger, actually. So you can actually see it adjusting as we change the size. Stuff like that. So I'm going to make it so that I can more easily edit this and update the logic. So I'm actually going to emit it. I'm going to emit that once, and I'm just going to have a load of these emitters in a group, and then turn the groups on one by one. That's how I did it in the actual thing. A cool thing that I like, that I added to the final scene, was a little bit of randomization in here, which I can make them all bigger zones actually. because they're quite small now. Okay, so now they're a lot more averagey smooth. But also we can then do this bit of randomization. We can use a keyframe to adjust this zone so that it's actually smaller, which means it's affected by less of the transmitters. So it'll be like more fine-grained. It won't be so averaged out between a large number of transmitters, depending on what this random number is. So we just wire that in there. And if we put that onto keep changes, then once it's done that, it will just stick. So we'll put that into here as well. And then we'll destroy. So that's a little bit of setup. It will be a bit more thermo-intensive until we destroy just that timeline. So destroyer, wire that into the timeline. So it will set itself up with a bit of randomness, and then it will destroy itself. So you can see now it couldn't get all of them, but you get this really nice chunky detail out of it. So if we just that to be less severe. Yeah, so if we just make that smaller like that maybe. Yeah, so it's kind of got some nice detail to it where instead of it being purely very smooth, it's like a bit more chunky. So I'll just show a couple of these features that I had here. So it's got required nodes, so I can just reduce that to 3 and then reset. So only with like a few nodes you still get quite a varied thing. And if you go like full tilt, then you can generate a terrain like this really quickly. I'll turn it off, and then I have a flat value which the blocks pay attention to. So flat is at 0. Then it's purely the percentage that it's actually sending from these transmitters. But when you push flat to be up, it kind of scales it so that you get more of these flat areas, the red areas. And then detail is that the size of those zones. So when it's quite big, it gets really smooth. But I like it when it's kind of has a bit more detail to it. And you could easily use this same thing to say the likelihood of a tree spawning or something. So like in these green areas, so instead of height, you could say in these green areas there's more trees and foliage, and in these low areas it's more likely to have like water or something. So this kind of heat map generator thing method can be used for procedurally generating all sorts of stuff for your game. Like this could be a built up city area, and this is, or like you got some towns and a village. This is a forest, and this is like a proper city and things like that. But then you can just emit one of these sensor block type things in any place on the map in like a random place. So if I just plopped one there, then it would have this high value. And it would say, oh, it's a high value, so that means I'm a tree. And then you'd emit something in a different place. Oh, this is a low value, so it's a house. So it doesn't have to be this detailed to still be really useful, to really get detailed values out of it. You don't have to have the whole world littered in these blocks for it to be useful. You can just like plonk down a block in a random place, and then now there's a feature there, but then you get similar features in similar areas, and you get these kind of naturalistic shapes come out of it.
Thanks for watching. I hope you learned something interesting. Go to patreon.com/TAPgiles to learn something new every day.